So I'm going to talk about Reactor 3 as a general update session to see or comprehend what the kind of thing we offer in this framework now. And yeah, let's go. So just to get the definition of what is Reactor Core, you know, it's a lot of TLDR slide like that you're going to see. But the definition of Reactor Core is simply a set of transformation and generation really already using publisher or subscriber. The two interfaces provided and the fact we have to implement them as well by the Reactive Streams specification. It's all about that. This jar is really all about that. And it doesn't do like remoting stuff. It doesn't do what kind of thing you can expect from Spring, for instance, or Spring Cloud Stream. It's really a very granular level we operate. We offer two types, basically. And these two types are just your tool belt for getting reactive, and that's nothing more. If you know RxJava, you shouldn't be lost. Especially, a lot of this stuff is inspired by reactive extensions. So Reactor Core provides this set of generator and transformer and a set of static API to create this transformer or instance method. We'll see a few examples of them. But why do we do that? It's simply because, you know, if you have ever used or looked at the Reactive Streams specification on the website, you will see like, you know, these two interfaces, publisher and subscriber. And really, that's great because, you know, if you have a user repository supporting a publisher return type like Spring Data, it's going to produce a user only when it has read the data from the database. So it could happen asynchronously or synchronously, we don't care. All we know is user repository.findUser is never going to block you. That's the first reflex you see when this thing returns a publisher. That means nothing blocking is going to happen when you call findUser, unlike when you return a user. That's something which is going to be blocking. One of the problems of the Reactive Stream spec, especially when you just deal with the publisher and subscriber interface, it's good in general, you know, it's a good practice to just deal with the generic interfaces, but in the functional world you need a bit more vocabulary and a bit more semantics as well. One thing we don't know about this return method, for instance, is how many users it's going to reply from new find user. Normally from the method name you can infer that it's going to return at most one user, but publisher, the specification doesn't enforce that. It just says, okay, it's going to return 0, 1, or n users. We don't know. So that's an issue with the plain specification. And beyond that, you would have to implement what we call the subscriber as well. And the subscriber is similar to a callback-driven framework or library. That means when you implement a subscriber, you have to implement all the method, which I shortened to 3 dots here, but you have to implement the onNext method, which is part of the subscriber interface, onSubscribe, onComplete, onError. Even if you don't need them, you have to implement them. But that's the callback offered by the specification. You know the specification is a jar with 4 interfaces. And that's the way it is. We keep it simple because it's already complicated enough. We just focus on the behavior, and that's what the spec should be all about. So why we do have a reactor on top of Reactive Streams? Well, if you start auto-completing, you will see maybe quickly why we have that. Because the only thing you can do with a publisher is basically subscribe. That's the only method you have on publisher. It's great, you can subscribe your own subscriber, register your callback, but what if you wanted to chain and add some transformation, some filtering, some micro-batching, all these use cases which are very interesting when combined with a Reactive Stream library. Well, the problem is there you only have subscribe, and that's really the core purpose of Reactor, having an API to decorate the publisher. And because otherwise you won't be happy, you will have to implement that yourself. And yeah, sad face. that's really the purpose of Reactor, providing a set of already done for you publisher, already proven, tested in actually different projects, developed in collaboration with a range of different people, and that's it. So 3.0 is really something that comes after, obviously a 2.0 and a 1.0. And if you have a 2.0 and 1.0, that means you matured some ID behind. It's not like we're new in the space of reactive, like, oh, let's jump on the bandwagon of reactive stuff. We've been questioning that stuff for a long time, actually. And I was working before with my previous colleague, John Brisbane, on Reactor 1. The purpose of Reactor 1 was to do a lot of stuff, but mainly do stuff fast, and we called that actually fast data library. And then we had Reactor 2.0, which was the first implementation of Reactive Streams, which had totally failed, and I'm happy to admit it, because that's from this kind of feedback you know where to improve your library. And the thing is, with Reactor 2.0, we actually learned more about how to implement the spec, and I can tell you and promise you one thing, implementing Reactive Streams is fucking hard, really, really, really hard. You don't want to do that yourself. Otherwise, you lose your mind, you lose your friends, you lose your nights. You don't want to do that. So you want to use something like prepackaged publisher or implementing publisher. And after 2014, actually Reactor 2 is widely used, surprisingly, but I'm happy about that. The problem is how we're going to migrate these guys to Reactor 3, which is another interesting question. But for instance, Grails 3, for the guys who remember Grails, Grails 3 use Reactor as a dependency, Reactor 2, and we will have challenges to make them evolve to Reactor 3. But at least with Spring 5, we start with a clean base, Reactor 3.0, and we develop for this reason. So we had existential questions, and it's no filter or no secret that we did ask ourselves, should we keep having a library called Reactor in Pivotal? And that was a real question, because we didn't understand actually what Reactor was doing. And that's why I started the slides with the real focus of Reactor, really about providing for you already done publisher. And that's the only purpose of Reactor Core now. And so we wonder what we do with Reactor. At the same time, there were questions, because I was kind of doing internal consulting inside Pivotal, I still do actually, to help people going reactive in different projects like Spring or the Cloud Foundry Java client as well, and all the stuff, unveiled or not. So I was actually collecting feedback from various projects, and the solution to not repeat the mistake of Reactor 2 and Reactor 1, trying to do too many things, being overly complex for something that's already hard to comprehend when you come from the imperative world. I collected a lot of feedbacks, and I switched myself from a lead position to a co-lead position. And I said, everyone, you're all co-lead with me. So that's really the people project. And that's the way actually the why turned for Reactor, because I said, okay, Spring guys, I know you don't understand what happens inside the Reactor project. I myself doubt about the project too, but let's discuss together what can it be useful for. And the first plan for Reactor was actually to be a hidden dependency in Reactor in Spring 5 with some kind of publisher factory and subscriber factory, no real API, just to help under the hood, under the cover, Spring 5 to do the reactive stuff. And that's it. But we came from a long way, and we extended the scope of the collaboration to other people, and that also accelerated the transformation into this focused library we have today, Reactor 3. So what is the use case that drove this change? At the same time, in Pivotal, we sell this thing called Cloud Foundry, and with Cloud Foundry, obviously, we try to promote the microservice architecture, because that's what we try to embrace with a cloud-ready architecture. And it came to me, interestingly, it came to me, actually that strikes me how many people don't consider the concurrency issue when you start doing microservices. And I don't like the term microservices. I usually use distributed systems because they're all just distributed systems in the end. People were starting using too much of the microservice architecture and starting decoupling the application into 3, 4, 5, maybe 6 application depth network hubs. So you have a gateway receiving client request, then this thing ingests the request and calls another microservice doing some stuff, calling another microservice, maybe calling another data store. But that doesn't come for free. I mean, who thinks that comes for free? There are physics laws like the speed of light. You cannot fight. It's we don't have a solution for that, except maybe a company called Lightband, but they have a kind of other solution. We cannot fight the speed of light. So that means, and you know these figures from Google actually, the difference between the latency difference between querying property into memory into your class is going necessarily to be different from asking a property to a remote service. And that's true. It's like 10 or 100 or even more sometimes if it's a really distributed network, millisecond difference. And the problem with this kind of architecture is if you have latency, that means you have something waiting for the response at some point. And what about the incoming requests keeping coming to your service, to your gateway service? What are they going to do in the meantime? Some stuff is already waiting for something else. Well, first they're going to accumulate in an unbounded backlog, which is the case with a classic servlet 3 or even 2 kind of a container like Tomcat 7 or 8. And they're going to wait somewhere indefinitely. So you have a mismatch between the speed of consuming remote services and incoming traffic, which keeps increasing because there are things waiting on the other side. And yes, that doesn't also come for free. At some point, your application is going to reach a limit if it's not the unbounded backlog provided by Tomcat or whatever, or JD, and it's not only an issue with Tomcat, it's an issue with any kind of container with a thread pool model. If you keep, accumulating at some point, there is no magic. The application is not going to work forever, and that's the real issue, because it's going to, at some point, tell you, I don't have memory, out of memory exception. It's going to tell you, I'm going to pause for maybe 10 seconds because I have so much to clean, and it's so hard to clean with my GC. I'm going to have this pause of death, which is really a pause of death. Your requests are going to be paused as well, and maybe timeout. And your application, in the end, becomes unavailable, and that's not great. And usually, the response to that, and we showed that in the keynote this morning, the response to that is aggressive scaling. We try to overcome the fact that the application is not responsive enough by adding a duplicate of the same application, which is not a great story for microservice, because you want to deploy more different microservices. You want to break down your architecture into functional, isolated components with different purpose. You don't want to use all your very expensive resources to duplicate the same application 10 times. And how far can you go with this kind of model? Because duplicating the application 10 times doesn't come for free neither. Once you start duplicating 10 times, and then more and more, the network is going to be bloated as well. So you have a physical limit anytime, anywhere, if you don't design for this kind of architecture now. And that's why, that's the excuse we had to, revive the project. And that was kind of Rocky style, America grade kind of comeback story, because I tell you, we went from the existential question to shit, how do we address this microservice stuff? So at first, some sales guy from Pivotal came to me and said, but if you're selling the story of using less instances to do the same stuff to our customers, they're going to pay less instances. And one specifically asked me that, actually. And I told him, no, the principle, what we try to do is not to force the customer to scale out aggressively the same application 10,000 times. We want them to really embrace microservice architecture, which is having one instance of this thing, one instance of this thing, one instance of this thing, but not 10,000 instances of the same thing. Otherwise, you're going to, of course, you're going to make us happy because you're going to pay the high price, but also AWS, also, well, also any kind of cloud platform, actually, or infrastructure. So I'm not trading off, the fact that we're getting more efficient with this kind of design. And the trade-off is some complexity, of course, but also the fact that you can deploy different microservices now, not only the same. So we came back and we worked together closely with a few group of people, including Cloud Foundry Java client, including the Spring 5 team, including even the Spring in general team, like Spring messaging, Spring integration, Spring Cloud Streams, Spring Data, all the Spring ecosystem. And we still have a story to expand here. There are other things to consider, like tracing. I need to discuss with the tracing team to see how we're going to integrate that with the tracing team, for instance. There are other challenges to resolve in this kind of new world, new deferred and composition world. But we work together now, which is a slightly but very important difference compared to before. So as I said, I'm now a co-lead, and every one of my colleagues is a co-lead of Reactor. And more than that, actually, because the influences not only comes from Reactor itself or Spring, it also comes from reactive extensions. And my partner in crime here is the lead of RxJava, David Carnock. With him, we created a project to actually find out the best way to implement reactive streams. And we call that reactive stream commands. We actually sponsor and host the project in the Reactor GitHub organization. And with him, we elaborated a set of transformation and generator implementing publisher. So basically contributed maybe half of the code of Reactor, which is interesting coming from the perspective of, I don't know if you use RxJava or not, but that's the way it is. And we were happy with the results. And now we just needed to wrap that into an API because the reactive stream commands project is just like our playground project to implement the reactive stream specification, but it doesn't really come with an API that is stable or whatever. So what we do, from this playground, we move the operation and we inline them into Reactor, so we don't depend on a dependency called reactive stream commands. We actually just move the classes into Reactor Core, basically, directly, and adapt it to our own API. There are more than the reactive streams command API inside Reactor. There are also specific Reactor operation, as we will see. But really, that's also, David Carnock is also what I consider a co-lead of Reactor, because he is behind a lot of ideas, and that's it. I get behind and I just aggregated a lot of feedback, because once you do that, you're not the only one responsible of the thing. If someone blames you, you can blame anyone else in the team plus David, etc. It's not only my fault now. So, hey, here we go. That was the David Carnock profile picture. Anyway, so we had this spheres of influence from Spring and reactive extension, especially RxJava. And now we have this Reactor Core jar you can pull from Maven Central or Spring.io repo. But also we are working around this core with extra project to help all the things to become reactive, like IPC, which is inter-process communication. And in that project, we host a few already very elaborated projects to map reactive streams to network stuff. So in IPC, you will find Reactor-NET. Yes? Yep.
I'm just confused with why is there Reactor Core? Why did y'all put Rx inside the core? Why is there two different projects?
Why are we different from RxJava? Is that the question? Why are we different? Why are not we RxJava? What's that?
Yeah, why didn't you just build on RxJava?
Yep. So RxJava 1 doesn't implement reactive streams. That's one thing.
So why didn't, so if it didn't implement it, why didn't you just implement it over there instead?
So because the project is not owned by an open source organization, it's owned by Netflix. And they have a different agenda. Netflix, as much as you can tell, at least from my perspective, it's a consumer company. It's not really a framework company, as far as I understand Netflix business model. And what they propose, basically, what they open source, like Estrix, like RxNet or RxJava, for instance, is whatever they use internally, and that's it. And then they maintain it. They had this great lead, Ben Christensen, who implemented the RxJava stuff, which has inspired, actually, Reactive Streams specification. But Ben left at some point, and every time, we had actually a keynote about that. Every time, like, such a great personality where everything is on him, all the code, ownership, etc., that's also a blow for the company in general. So no one currently, at the time I speak, is committing to RxJava in Netflix right now, which is a problem for us. We are Spring, and we don't really like uncertainty as well. We need to have some kind of control. And at some point, they thought about dropping RxJava. Now they revive it with RxJava 2, and they implement the publisher and subscriber stuff. But we've been dancing with the kind of stuff we've been communicating with Netflix, and they didn't know actually what they're doing with the RxJava 2 or not. So, and that was frustrating actually the RxJava lead, which is not working for Netflix neither. 100% of the code now in RxJava is not from Netflix, which is another interesting fact. And the thing is, this other guy, David Carnock, now the lead of RxJava, is a researcher. He works for academics in Budapest. And he wanted to continue progressing on this stuff, but he couldn't because no one was responding to him on the Netflix side. So we created this research project. And because at some point we also thought that the project was going to die, basically, we just continue on until like 1 month ago, the project RxJava 2 wasn't existing. It was an ongoing, a never-ending discussion. So that's part of the reason. The other reason is to keep to just two simple reasons, actually, because there are many ones. But anyway, one of the other reasons is actually we don't want to be married to the reactive extensions. So we want to be pragmatic. And our API can smell like reactive extensions, but we don't have to respect necessarily all the reactive extension methods. So taking, for instance, the jar size, you will see there is a difference in terms of API coverage of reactive extension. We are like 900K kilobytes, and they are like 1.5 megabytes and keeping increasing, because in RxJava 2, there is an extra new type called flowable, which is different from observable, which is different from single, which is different from completable, that implements reactive streams. Because the original idea of reactive extension was not to implement backpressure. And that's from the word from the lead of this whole reactive extension thing, Eric Meyer. He doesn't want backpressure to be included in reactive extensions. So this thing is frozen in time. But RxJava wanted to do that, and they started with one with some backpressure stuff. So they had to create an extra class called flowable. We're sticking to just two classes. But that's only two reasons. The focus and the coverage we want to do, the fact with Java 8 as well, they're forced to stay on Java 6 too. That's another reason. This kind of thing. And I think we're fine. We're not competing because my best friend is the lead of RxJava now. So the target for themselves now is more the enormous Android user base they have. 70%, I said that a few times already, but 70% of the users of RxJava are Android developers. So because of the Java 6 support, and with Java 8, and it's just arriving in the world of Android. So that's a few reasons. I could go on. Also, Reactor is a core dependency of Spring 5. It's hard for a company editing frameworks, even open source framework, to depend. That's the first time in Spring history, which is 14 years, or more even. That's the first, no less. That's the first time in the Spring history there is a dependency below Spring Core, which is Reactor Core. And that comes back to the need of control, the need of having this kind of lifecycle control as well. So, and we are sometimes different, but that's reason enough, I think. I don't want to elaborate too much because I'm not thinking also as competing. And if you use Reactor Core, and we'll see that in one slide, you have direct support for RxJava. We communicate directly, and which has been also contributed by the RxJava lead. He knows the best how to convert Reactor to RxJava. So that's cool. If you use that, you're still in good position. You can still use Spring 5, for instance, with RxJava. We're not going to haunt you and tell you and spam you with marketing mails to use Reactor. We're totally cool with that. But we cannot be the same. So a smarter publisher, you've seen already that the publisher, if you autocomplete, is going to provide you subscribe method, and that's it. But Flux is a smarter publisher, like observable, with a few methods, not every time the same signature or semantic than Rx, but mostly, so we don't lose people. The people who know RxJava will never be lost with Reactor because they know some of the behavior already. But we implement this kind of operation chaining, if you do Flux just with free value, free strings in that case, it's going to return a Flux. Like in RxJava, if you do just, it's going to return an observable. Observable.just, sorry. And Flux implements publisher. And that's great. If you use, for instance, Spring 5, you can pass a reference to this Flux to whatever Spring 5 expose that needs to accept a publisher. That's interop at play. We can also communicate directly with Akka, because Akka Stream implement publisher and subscriber, so they can subscribe to our Flux, or we can produce to Akka and vice versa. So that's great. We can also play directly with Ratpack, because Ratpack, for instance, has a method that accepts in the signature directly publisher. You just have to pass a reference to Flux, or the next type I will present, mono. So the completion stage is maybe something we can argue a bit more, because there is no real backpressure in the concept of 0 or 1 data at most. But there is a case to be made still for having a reactive library that implements a single or 0 use case, because the completion stage is push only, and that forces you to actually trigger maybe the processing logic of the completion stage when you actually call a method with completion stage, where a mono, using the same semantics of publisher, will be only asking data if you have subscribed and if you have asked for data with request. So it's a push-pull, actually, which might be nice. It's kind of deferred completion stage, plus, of course, the API, like in RxJava, with single. We have a lot of method you can use from mono to represent something that will produce at most one result. That's great. If you can notice in that slide, actually, the block method in the end, which is equivalent to, in RxJava, equivalent to 2 blocking. And this thing is going to transform you mono, whatever you do with the mono chain you're actually composing with. The map is going to transform the delay coming into a string, Spring 4, etc. But because it's a delay, it's non-blocking, it's going to come at some point. It's triggering in 3 seconds, actually, in here. Block is going to force you to block the main thread you currently call block and get the value from the chain, which is not good. We don't want to do that. We have it. Sometimes we need it for testing, but I strongly advise to not use it. That's why I say no. And what you should use in this case is simply subscribe, and subscribe to it as you subscribe to any kind of publisher. Not that we have extra subscribe method. You don't have to pass a subscriber. If you pass nothing, we're just going to request the data from the mono. You don't have to pass a callback. But if you want to, or if you even want to pass a subscriber, you can. So One of the things we try to address in Reactor Core as well is having a single jar. Before in Reactor 2, we had something called Reactor Stream with a stream and a promise type. The thing is, now we're using Java 8 and having a stream called stream competing with a stream called also stream from Java 8 will be kind of confusing. And this space, you might not expect that, but this space is quite busy actually, and finding the right name is hard. So Flux is the name we've chosen to implement this 0 to n items type, and mono is the type we use to implement the 0 to 1 behavior. And also, we made an effort with this jar. If you see, that's a package, the actual package structure. It's not really a lot, actually. You have mostly everything interesting, which is 2 or 3 classes in publisher, Flux, mono, and an extra one I will talk about. And that's basically where you will spend most of your time. You won't really necessarily see any other things. The other things you see here, the adapter is just to bridge to RxJava 1. There are 2 classes inside. And to Java 9 support for Reactive Stream, because effectively Reactive Stream is in Java 9 now, not with the same package name, so we have to have an adapter. But it's really about the publisher, and also about the scheduler package, which has only really one public class, because a difference we have, for instance, with RxJava, we don't have package cycle, which unfortunately RxJava suffers. Might be hard to read sometimes the RxJava code for this reason alone, actually. But the scheduler, in that case, is going to hide a lot of scheduling. So think scheduling as a kind of super executor with some extra constraint. The scheduling package is going to be only exposed through the interface it implements, so you can implement your own scheduler if you want to, and a factory of scheduler called schedulers. But everything else is hidden, and that will be the same with publisher, actually. All the implementation we have, like to create the map operation, we have something called Flux map. This thing, you will never see that in your class path because it's actually package scoped. We only show what the consumer API should be. We don't show the internal. That's a difference because we want to be in control of that. We don't want to add extra overhead to people's mind. It's already hard enough, as I said already a few times, to translate to a reactive world. So, one of the good things inherited from the reactive extension model is the freedom of execution. And actually, just coming back to this slide, see here, the Flux just doesn't necessarily say anything about threading. We have a flat map inside. There will be something about threading, but the Flux just is just a synchronous thing. If you start subscribing to it, it's going to subscribe to it and do the stuff synchronously in your main thread or whatever you used to call the subscribe method. But that would have worked as well if you wanted to go asynchronously at some point, because some operation can be costly, switch to another thread. And that's really what it is about in the scheduler package. Oops, I'm going to have to go to all the animation, sorry. Yeah, it's all about that, the freedom of execution, choosing whatever the thread you come from. We're happy with that. If you come from asynchronous thread because your database has had a callback on a different thread and wanted to publish some data into the Flux, we're happy with that. All the stuff we do is basically implementing thread-safe operation that deal with concurrency safely and efficiently. And the scheduler is just here to help you switch from a thread to another if you need so. So we work with synchronous mode. We work also with asynchronous mode if you use the right scheduler. And that's great. This model of execution is quite a differentiator, not from RxJava, of course, but another framework, Stream, because in that model, for instance, you will be asynchronous every time. You will be forced to use an actor model to support your Stream chain. And I'm not saying that everything should be asynchronous. Some use cases are good with synchronous. Some use cases are good with asynchronous. We give you the power to choose, basically. We want you to make that choice. It's very easy to make that choice, so we expose that through a coupled method at most. And if you want to do that, you're free to do so. But if you want to just reuse the current thread, That's also fine by us. And I like this, this kind of freedom. Because I say you shouldn't be asynchronous all the time. It's already, complex enough, and you're free now. We really free you. You can do anything you want. And yes, fuck everything asynchronous. You have to choose. So, another thing we try to do with Reactor 3, we try to expose the more Javadoc, and for that we worked on the marble diagram because that's the best way to explain a sequence of things happening over time. So the Flux and Mono, for those who were in the session before, are clearly documented with a marble diagram for each of this stuff, each of the operation you can find in the API of Flux or Mono. Clear difference from where we come from in the previous Reactor version, and you can browse that online on the site. We have a new site as well, but I'm not focusing on that neither. So, and that's great. Also, this interesting guy here has written a series of posts. Meanwhile, we don't have a reference documentation with a clear tutorial beside the reactive, the Rx Lite hands-on. This guy, Dave Sayer, for those who didn't know, has written on the Spring.io blog a series of 3 blog posts you should read because it's really taking, as usual with the Spring team, a pragmatic approach to all this stuff. Especially, the day I've convinced Dave it was a great thing what we were doing, I felt like rewarded because that's someone who challenges you before you try to, bring extra stuff, especially if it's connected to some hype. This guy is very good for detecting bullshit. And then his blog series is very good to learn about the reactive stream stuff and Flux and Mono. So, just Spring.io blog, and you will find this blog post. You don't have to copy and paste this link or try to memorize them right now. Another thing we have, so since we're not married to reactive extensions, we are not forced to listen to Eric Meyer every time he's unhappy with the reactive API the RxJava guys provide. We can do anything we want, and especially anything that matters to us, which is, for instance, bringing developers from imperative world to reactive world. And that's very interesting because we have created a few operations that helps you bridge from any kind of asynchronous library or even synchronous library to reactive. This create operation, for instance, is quite interesting because you can the HTTP listener is fictive, but you can actually register, you can create a mono from arbitrary code. So it takes a callback, of course, that's a trade-off. But inside it, you will receive as a parameter, you will receive when someone subscribes to you, you will be called with this thing called emitter. And this thing is going to be useful for you to complete with nothing or complete with a data. That's what we do in the line emitter.complete or emitter complete with a body in lowercase. That's great. And we can attach a listener, to whatever. It could have been a swing, an action listener. It could have been anything. We have the same for Flux. We can even subscribe cancellation. We can bridge cancellation. So this kind of API is quite unique as well. And we also do that not only for Mono, because Mono will force you to respond with at most one data, but the Flux allows you to do that with the Flux create. You can also Flux create and call multiple times emitter next with some data anytime you want. So we can help you bridge nicely like that. Another thing we have implemented that didn't exist in all the libraries until very recently is the concept of operation fusion. So, doing reactive stuff is nice, but I don't know if you have already started working with that and place a step debug point inside one of your callback, or just have an exception in one of your callback. But you will notice probably a kind of immense stack trace at some point, because it's really, really, really recursive. Somehow we on onX on this operation, then on onX on this operation. We pass the data from each operation to another. So if you have an exception downstream, it's quite a daunting stack you're going to receive. And it's not also very efficient sometimes. Some operation implements queuing, for instance, because it needs to buffer some data, because there is a boundary with another another thing, another stream of data coming from another thread. Every time there is, two stream of data coming into the same place, we need to have this kind of buffering scenario with a queue, etc. But that doesn't, creating a queue doesn't come for free. So that is the two things the operation fusion is all about. We try to first avoid internally having 10,000 operations. If you write, for instance, we have an operation called merge with or concat with. If you write 10 times concat with in a row, we're going to translate that into one concat method. And that's great because otherwise you will have like 10 times concat with in the stack. And that's not good because there is also a limit on that, stack overflow. And the other thing is, as I just mentioned about the buffering, if the parent operation is synchronous, and its parent operation is synchronous, and its parent and so on, until another boundary, another queue maybe, we're going to actually bypass the reactive stream specification to immediately avoid having this request lifecycle the reactive stream forces you to have, and sometimes the ONX stuff as well that results. We just kind of merged or reused the queue upstream and pull from this queue upstream, avoiding creating a queue downstream. So basically, if you have 10,000 flat map in a row, we're going to use a few queues instead of 10,000. And that's great as well, because you don't want to create 10,000 queues. It's already hard to debug one queue, so having 10,000 of them is very hard. And we have these two categories of fusion, as I said, the macro fusion to try to merge operation, and we have this micro fusion to try to avoid this queue creation. Very, very efficient. Another great thing we have unique as well in Reactor Core is, especially Reactor 3, it's new, is an operation called parallel class. The extra type I didn't mention with Flux and Mono. There is an extra one called ParallelFlux. Actually, you can get it from a Flux using the parallel instance method. So with this parallel method, you can actually starve your CPU up to how many you want. So we could have used nothing as parameter. We use 3, but if you didn't use anything, it will use as many CPU you have on your current hardware. And we will have tried to use all these CPU resources to do the stuff inside the purple block. So what we do here is simply say, OK, I'm going to actually split the processing of a given stuff, in general, a blocking part. And I'm going to split that across all my CPU, or only 3 of them. I'm going to ask a specific thread to go into each of these parallel rails. For instance, we call them rails as well, or parallel tracks, or whatever. And on each of these tracks, we're going to start accumulating. So we use a collect operation. We're going to start accumulating into arrays. So it's kind of micro-batching. And then we turn that back into like a join. We turn that back into a sequential one. So from the n of 3, we come back to a one rail executing at a time. And then we can continue using, because sequential return the Flux, we can continue using the Flux API. Notice also we use something called test subscriber, which is interesting if you want to start doing assertion. You won't do that, of course, in production code, but if you want to do that in your test, for instance, we have this subscribe with, which is the same than subscribe, but returning the type you actually pass in. So the subscriber you pass in. So that allows me to actually chain the await method available in the test subscriber, which is nice. So you can see the world test actually standalone here. So that's great, for starving CPU based also on demand. For instance, a track is going to be maybe at some point, we don't control who's going to do more work than other ones, except that some tracks are going to be so busy for some reasons than other tracks, other parallel tracks are going to take over the overflow and continue doing the work. So we really do a kind of fair distribution of the data inside this block. So, and that's great. That's very efficient. It doesn't seem like that, but that's really a game changer. David Carnock, again, is really, is really neutral on this stuff, because he even does benchmark that place RxJava in a less good position than Reactor. And if you start using, the parallel stuff, for some cases, for some scenario, You can find this scenario, for instance, inside his own repository. It's going to be great. You see, the less lengthy the bar is, the more efficient it is. And we compare every time also to the Java 8 specification, the Java 8 utils, so you can have parallel streams with Java util stream. It's not really about latency, it's just about pushing data. Still, that's the fastest way to do things. And every time we compare to that to see if we're just slower than that or as efficient. And really here, the difference is very minimal. And that's great. That's really great. It's a useful tool unique to Reactor Core 3. I don't know if you know actually this show. It's a new show from HBO called Vice Principal. And I don't know if you know this guy. He did another show called Kenny Powers, which is very good as well. But yeah, that's great to have this kind of efficiency, directly inside Reactor as well. So coming back to the question, and I know there are a lot of questions around this, RxJava 1 or not. We have, we're really friendly with the RxJava world. We can convert, to RxJava 1. There is a class called RxJava 1 adapter with this statics method, and you can do all kind of translation from one to another. Obviously, if you use Spring 5, it's going to be done for you automatically. If you type your signature with observable, even if internally they use Reactor, they will be using the adapter we have to convert it to unobservable, so you can keep using your observable stuff if you want to. And it's really about RxJava 1 because that's RxJava 1 that doesn't implement Reactive Stream, not yet RxJava 2. We wouldn't need that for RxJava 2, for instance. Well, yeah, some sort. And we have the same thing for the new incoming Java 9 feature, which is called flow.publisher. So see the subtlety here. They didn't call publisher, which is the same specification than Reactive Streams. They call it flow.publisher. It's a kind of interface called flow with inside 4 sub-interfaces. So 4 sub-interfaces, so publisher, subscriber, the same thing than Reactive Streams, except it's in a different package. So we have to adapt. But fortunately, it's already available in Reactor 3, so Spring 5 is happy because they want to support a lot of stuff in Java 9, and they will be able to directly support the Reactive Stream stuff from Java 9 as well. And we go further because we've seen, this kind of thing could apply to other, including the homegrown platform of Reactive Extension. It's kind of invading back, but anyway. We kind of extend this reach of, dealing correctly and rightly only on on backpressure thing with Reactive Streams. And this concept of backpressure doesn't exist in Rx.net yet. It exists in akastream.net, but not in Rx.net. So why not porting that to .net? And that's what we did. So that's purely Rx-like, but with backpressure on .net already. I didn't do any of this stuff, actually. It's, again, David Carnock. So you can see to a point he's embedded in. But that's great. And you can already, it does actually some usage. I didn't do advertising before about this stuff, apart from a tweet maybe a month ago. But you can already use that. It's all on Nugget and use that in your .NET stuff. It's used by some people already. So we have that, which maps effectively the same API you have seen in briefly in the Flux and Mono from the Java one. We also have the same thing for JavaScript. We implemented in TypeScript directly all the same Reactor Core extension. So if you have a Node.js application, for instance, or if you have an AngularJS and you don't want to use the RxJS stuff, which again doesn't implement the backpressure stuff, you can use the Reactor Core TypeScript. Bear in mind this thing is, it's on NPM, of course, but bear in mind this thing is still a work in progress, and we want to see to which point we can go with this kind of thing, especially in the microservice world. If you have a Node.js application talking to a Spring Boot application, etc., that would be interesting to have a kind of similar feel between these applications. And that's really what it is all about, having the same semantics applying across different platforms. And I'm not talking about this, a solution a la Vertex, for instance. Vertex implements, for instance, the JavaScript stuff for supporting vertical. But in that case, it's really a pure JavaScript library. You can see it's you have to pull it from NPM to use it. It's not using Nashorn whatsoever. It's a JavaScript library, and we are not a platform like Vertex anyway. We just like two types with operation in it, and that's it. So that's it. The thing I want you to remember is everything reactive is not maybe the solution. You know, there might be an overhead. I did a small coverage of the kind of unique stuff we can find into Reactor free. You know, having a kind of listing of the method wouldn't be interesting, I suppose. I did that in my uni days 10 years ago. It's boring enough. But I wanted to show you a kind of reach we try to have, especially to answer the question, why is it different from RxJava, for instance, or ArcaStream? We have all these few things unique to Reactor Core, the freedom of the model of execution, this operation unique as well, the bridging, the fact that we have a condensed API. That's great, but should that be invading all your code? I'm not sure. I myself just advise to use this Flux and Mono stuff for anything that takes time. So you wouldn't decorate an access to memory object or collection or whatever with that. I know a few people do that because it's consistent with the rest of the API they actually implement. But you know, if you have a getter, for instance, get user count, you wouldn't return a mono of long for that. You would just return a long, and that's great. And there are a lot of use cases like that. We need to keep being pragmatic about the use of this stuff, because it can be a nightmare at some point when you have too many of this stuff, and your team is not all up to date on reactive programming, and then they have to maintain that, and then classic stuff, they will reject what you've tried to force upon them. So use that with pragmatism. It's powerful. I'm really proud of what we've achieved with that framework now, library, because we really lightweight, or we try to. But be pragmatic when you use this thing. Just use it if you want to decorate an operation that takes time, not anything else. Please don't overuse it. It's back on the groovy days, it was the same thing saying don't use dynamic stuff everywhere because you kind of lose everyone at some point. There is a case for using this kind of thing. In that case, the case is anything that takes time, and that's it. Stick to that, and that would be good. So, yep, that's practically all for now. We have all the session, fortunately, tomorrow. So if you had enough of reactive today, that's good. All the session, interesting session tomorrow. So one is how to implement such an API using Mono and Flux precisely, and the feedback and the experiment. The feedback loop we had actually with this team was one of my greatest I had in my career, and lucky enough I had this very close relationship with this team, and I namely want to, precise, Ben, if you can raise your hand, and your team as well. Please, Steve too. This guy have created, this new version of Cloud Foundry Java client, exposing, things like Flux and Mono, and see, that's an exact pragmatic use of reactive programming. Why do they use Flux and Mono for a client that just, do requests to REST API, the Cloud Foundry REST API to deploy, etc., etc.? Because it takes time. Especially deploying, it's not even going to be 2 seconds in that case, or 3 seconds. Sometimes this thing can take more than 30 seconds. Do you want to block the rest of your application if you want to deploy, especially when you use that, you want to orchestrate, etc., your deployment of applications? It's actually very useful as a DSL to orchestrate your deployment of application, but that's a stretch. If you don't want to, that's a specific use case you want to focus on. It's a thing that takes time. So if you call the client, list all application from Cloud Foundry from your organization, you will receive a mono because it's not going to be immediate. If it was returning a list, then the application would be frozen for 5 seconds maybe. That's not great. And the joke is now to actually help the Cloud Foundry controller to scale better because it's too fast now on the client side. But that said, that's a very interesting use case. The code is beautiful. So if you have a look at the CF Java client on GitHub, please, yeah, do have a look at that, because that's the greatest example so far had in mind to explore how we use and combine this reactive API. And there is a session tomorrow. What time is it, Ben? 9? In this room?
Yes, actually.
So tomorrow at 9, you will have a greatest example of use of this stuff in real world, not as an update of Reactive Stream, Reactor Core 3.0. Another one we're exploring, which is going to be interesting, unfortunately in competition with schedule problem, but in competition with the Ben talk, is the Reactive Kafka one, where they experiment with a translation of Kafka and Kafka producer and consumer into the Reactive Stream world. And same, they translate that to Flux and Mono stuff as well. So that's an interesting case to explore, because you know, a remote boundary is a typical thing that takes time, and how do they translate that into Flux and Mono is something you want to look forward to. Especially the lady behind this reactive Reactor bridge to Kafka is an Apache Kafka committer. So she knows her shit, basically, about Kafka. And I tried to complete all the, actually a lot of the CF Java client team helped the lady to improve their knowledge onto Reactor stuff, because they know. So if you have any question, actually I thought I didn't use all that time, but wow. If you have any question, it's time. Otherwise you can run and say, holy shit, I just want to forget all of that now and have a drink. Any questions so far? That's great. I actually want to have a drink too. Good. Thank you very much to come.